So welcome to AZ Science TV. We are going to be looking at graph plotting today. You know, physics graph is very important. So we are going to be looking at how to plot graphs in physics. This is very important. Most students are finding physics graph very, very difficult. In fact, in the just concluded WAEC, some students even told me that they were not able to finish their work. Yes, they were not able to finish their work, which means they were only able to plot one graph. That was what a student told me. One of my viewers told me that he was only able to plot one of the graphs. I know graph actually helps to boost your score. Graph and table, that is where majority of the scores are embedded. That's why you have enough scores to boost your performance to excellence in physics, especially in the area of practicals. So we are going to be looking at how to plot our graphs speedily. Okay, I'm sure that you actually saw 5 minutes. Yes, it's possible. If you actually follow the steps I have on this table, then you will be able to plot your graphs without any stress at all. Now, I'm going to show us the experiment I did. I conducted an experiment using a glass block. Okay, I know most of us usually run away from glass block experiment, but I can show you this can give you high scores. Okay, although it takes more time, but if you're able to beat that time, it will give you high scores. That's why I always encourage my students in this school to always do it. Okay, in the school where I teach, I encourage them to always go for glass prism experiment or glass block experiment. And that is one of the experiments in the coming NECO examination. So remember that physics will be coming up, physics practical exam will be coming up on the 2nd. So that is why I have decided to come here to make sure that we are able to plot our graphs. No student who is a viewer on AZ Science TV is going to complain of the graphs are difficult. No graph is difficult. It's just for you to understand how to plot graphs. Now, it's not all about accuracy, but speed, because how far and how fast, including accuracy, will help you to succeed. Now, these were the values I got. Okay, if you check, these are the values I got. They are real value. This is 25, 35, you know, I got 25, 35. I got 26.5, you know, a lot of them. I got a lot of readings. That's about 5 of them. Look at it. Now, I got the sign. These are the sign of the angles of incidences that I took. These are the signs of the angle of incidence, okay? Sine I is 0.423. What is I? I is 25. So sine 25, here is 35. Sine 35 is 0.574. Then this is sine 45. This is sine 55, and this is sine 65. So these are the values. Then this is I minus D. Okay, the sign of I minus D, these are what we got. All right? So if you want to check the experiment, don't forget to watch one of our videos, okay? Watch the videos on glass block by AZ Science TV. You are going to see it. Now, let's not waste our time because this class is all about understanding graphs. I don't want us to shift our mind into something else, okay? Let's just focus on understanding graphs. But before then, I want to know how many of us are with us. So how many of us are with us? That's very important because this how many persons are going to benefit. So please do well to share this video to as many as you can. Okay, share it to many persons because as the practical is coming, I want you to succeed. Okay, you will do well. We are going to be using this graph after we are done with filling these empty spaces. I want us to fill these spaces. I will tell you how we are going to do it using what I call scale factor. I'm going to write it on the board. Scale factor. There's what we call scale factor. Scale factor. I'm going to use this scale here. Okay, this scales 1 cm to 0.1 units on the vertical axis. Then horizontal axis, we have 1 cm to 0.1 units. So we're using the same scale, okay, because we're able to accommodate the scales here. I will also tell you how to choose scale. You will learn how to choose scale properly, okay, because on that day there may be a slight difference between my graph here and the one you meet in the examination hall. But don't worry, it's still the same procedure. And we're going to choose our scale, okay. But before then, I want to be sure. So how many of us are here with us so that we know how to proceed, okay, without much stress? Okay, let's go. Please do well to share the videos. Okay, now I'm going to begin from this. Okay, so we are starting without wasting time. You can see this is the table from the values I plotted, or from the values I got from my experiment. These are the tables. All right, these are the table of values. These are the values or observation table. Now this is what I'm going to do. Remember, physics graph is decimal. Yes, it's decimal graph. You can see that the decimals here are just too much. So if you are not bold, if you are not scientifically bold enough, you won't be able to plot this graph because they look very confusing. But I can assure you, it is the simplest thing you can ever do. Okay? Now what we are going to do is this. Look at the trends. Let me show you the trend. Let's show us the trend, okay? Yes, let's look at the trends. This is 0.4. Can you see now? The first number here after decimal is 4. The next one is 5. Can you see it? 0.5. 0.7. Can you see it? It's only 0.6 that is missing here. There's 0.8. There's 0.9. So it's like 1, 2, 3, 5. Do you get that? That's what this one look like. Then we can choose our scale, okay, at the vertical axis. This is sin I. We are using sin I on the vertical axis and sin I minus D at the horizontal or on the horizontal axis. So what we are going to do first, you can see there we have number of tiny boxes. Number of tiny boxes. You can see that we have very small boxes here. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. If you count it, there are so many. The smallest box, all right, for 1 cm now we have 5 boxes. For 2 cm we have 10 boxes. So just look at it as we proceed. Okay, we are going to find the value of each of those smallest boxes. That's what we need to actually plot our graphs. No stress at all. In 5 minutes, you will plot your graph on the day of NECO Practical Physics. So let's proceed. Now, let's look at the vertical axis. Remember, this is the vertical axis. We are using 1 cm to 0.1 units. First, why? Because you need to choose your scale yourself. You can see that the highest value here is 0.9. Okay, at the vertical axis, at the sin I axis, the highest value here is 0.9. So we can approximate it to 1. We can approximate it to 1. So let's look at it from here. If it's 1, then it means we can have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Then this is 1. So just take 10 boxes. Okay, 10 boxes. And each of the boxes are 1 cm. Okay, and each of these boxes have very tiny boxes, 5 tiny boxes. Take note of that, please. So we are now going to look at what we are going to choose here. This is able to accommodate this. Now let's look at this. This is 2, 3, 4, 5, 6. Can you see it? Yes. Don't look at it like a decimal. Look at it like a whole number. Okay, this is 2. Okay, 0.2 is 2. Okay, that's 0.3, 0.4, 0.5, 0.6. So this one is like counting 1, 2, 3, 4, but in decimals. Then we will check. The highest value is 0.6. So we can start from here, okay, and count 6. 1, 2, 3, 4, 5, 6. You see? So we are also able to accommodate this value right here. This is what I'm now going to do. I'm going to write the values. I'm going to draw the axis. Okay, that's the vertical axis and the horizontal axis. I'm starting from here because it is big enough. I'm sure we can see it very well. So I'm going to draw my line from here. Yes, I'll come here and do the same. Yes, just bring it down. So I have drawn my vertical axis. Once you draw this axis, in order not to lose your mark, any mark at all, remember it is a vector quantity. So this point here must have arrowhead. Don't do without the arrowhead, please. Fix this arrowhead. It has a score. Then we are plotting sine I. Don't forget. So write sine I. This is sine I on the vertical axis. Then let's look at the horizontal axis. Okay, horizontal axis. So we can start from this point here for the horizontal axis. Horizontal axis. So we'll start from here. We can count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's up to 10, or we can bring it down. Okay, can just bring it down here. Yes, I want to do that now. You can see. Then we draw to this point. So we have done this. Then we are going to draw the arrowhead, just like the way we did arrowhead here, this point here. Then label it. This is sine I, which is this one here. So at this point here, to be sine I minus D. So we are going to write sine I minus D down here. Sine I minus D. So that's what we have here. Then let's proceed without wasting time. So let's number it, okay? Starting from 0.1 to 0.9 to 0.9 and even up to 1. So this is what I'm going to do here. This point here is 0.1. The next one is 0.2, followed by 0.3. Then we have 0.4. Then we have 0.5. Then 0.6. Okay, then we have 0.7, 0.8, 0.9. We are done with the vertical axis. You can see the way I numbered it based on the scale, because we are using 1 cm. From zero to this point is 0.1, then 0.2 up to 0.9. You can even make it to be 1. Okay, you can make it to be 1. We can make it to be 1. So just write 1.0 at the end here. Okay, then this is the origin. Remember, we are starting both graph from the origin. So I'm going to write 0, 0. Whenever you are starting from the origin and you are starting with 0, 0, look at it. Okay, we are starting from 0, 0, all from the origin. All right, then let's move this way too. The same thing, 0.1, 0.1, 0.1. Then here we have 0.2, then 0.3, 0.4. Then we have 0.5. Then we have 0.6. Okay, then the next one is now 0.7. You can see, so this is what we have. You can see the way I'm gradually building up my graph. This is how you are going to build your graph, but don't waste time, okay? Don't waste time. Build it fast, all right? Let's do it very quickly so that we can plot the two graphs. Remember, we are plotting two graphs on that day, so there's no need wasting time. Then on top here, write the graph of sine I against sine I minus D on top. That is the title of the graph. Then write the scale. The scales are this. Don't write it at the bottom, write it at the top here. The scale will be at the top. The scale is vertical axis 1 centimeters to 0.1 units. That's for the vertical axis. Then for the horizontal axis, 1 centimeter to 0.1 units. So same thing. Yours may be different on that day, but let's use same thing here. Okay. Now we proceed. What am I going to do? I'm going to use my calculator. Okay. I'll use my calculator. What am I going to do? Just listen. You'll be shocked. You'll be amazed as to what I want to do now. I hope you are with me. I hope I'm not talking to myself. Please do well to share the live stream so that more persons will benefit from this. After today, you will plot that graph on that day in 5 minutes, if not even less. Let me show you what we're going to do here. Remember, let's focus on this sin I first, which is this one. This is sin I values. The first values there, if you check, the first value is 0.423, approximately 0.423. I'm going to compute it with this calculator now. Remember, from this 0 to 0.1, there are 5 tiny boxes. 5 tiny boxes from 0 to 0.1. 5 tiny boxes. Use that, count the number of 5. That's 5 tiny boxes. Use it to divide 0.1. Okay, 0.1. So I want to do it now. 0.1 divided by 5. The answer is 0.02. That is what you call the scale factor. Scale factor. So the scale factor here is 0.02. Scale factor is the value of the smallest box. Smallest box. That is scale factor. Okay? The value of the smallest box. It is that smallest box you now be using to divide this one to get the number of boxes here. Or the value of one box. The value of one box at this horizontal level here, the value of one smallest tiny box is 0.02. So let's use that 0.02 to be dividing each of these values. I hope you can see me very well. We are dividing each of these values with 0.02, which is the scale factor. Okay, so for the vertical axis, the scale factor is 0.02. 0.02. That's for this vertical axis, 0.02. So use 0.02 to convert this one to the number of tiny boxes. I will tell you what we'll do with it later. So let's begin. Let's begin. Here we have 0.423. So I'm 0.423 divided by this scale factor for the vertical axis. I'm sure you know how we got the scale factor. We got it by using 5 smallest boxes to divide 0.1. So let's proceed. I've got it 0.423 divided by 0.02. And the answer is approximately 21 boxes. So write 21 here. Don't show these ones on your graph, on your answer booklet. Do it on a different paper. Okay? These 21 boxes. What it means is that you will count 21 boxes from the origin to that point. To plot this one, you need 21 boxes. You don't need to be looking at the decimals. Just count the number of boxes. So let's go to the next one. The next one is, I'll make it faster for us. The next one is 0.574. So 0.574. The answer is 29. So approximately 29 boxes. So you will count 29 boxes from the origin to this point to plot this one. Not plotting this one again. Just plot. Once you get 29 boxes, plot that point. Let's proceed. Here we have 0.707. 0.707. Okay, here is 35. 35. That's 35 tiny boxes from the origin. Please take note. Then the next one is 0.819. 0.819. We will get 41. So this is 41 tiny boxes from the origin. Let's do the same to this one. This is 0.906. 0.906. Yes, that is 45. You can see it here. Very easy. That is what? 45. So this is 45. 45 tiny boxes from the origin. Now we are going to do the same thing to the horizontal axis. So let's look at the horizontal axis. Okay, if you have any question, just put it in the chat. Okay, just put it there. Just put hashtag question. Okay, then let's proceed to the next one. Look at this particular one. It is the same thing. You see that it is the same 5 boxes, right? Same 5 boxes. So which means it's the same 0.02. On that day, yours may be 10. Okay, yours may be 10. Yes, it can be 10. So if it's 10, use 10 to divide the first number from the origin. The first number, this is 0.1. Okay, that gives you the scale factor. It is the same thing. Okay, divide 0.01 by 5. You are going to get 0.02. 0.02. So which means the scale factor is still 0.02 for the horizontal. It's the same with the vertical because we are using the same scales. Okay, we are using the same scales. So let's proceed. Convert these decimals, these carrying decimals. Okay, convert the decimals to the number of boxes. So we want to do it now. This is 0.259. 0.259. That is 13. Approximately 13. Approximately 13. Okay? It is approximately 13. Then the next one is 0.304. 0.304. 0.304. Now we are dividing 0.304 by 0.02, which is the scale factor for the horizontal axis. That gives us 15, which means we are plotting 15 boxes against 29. You see, count 29 along the vertical, count 15 along the horizontal, and plot it. No need for the decimals. You don't need decimals. Okay, it is very, very easy. Go to the next one. The next one is 0.431. 0.431. It is 22. Approximately 22. So we are counting 22 boxes horizontally. Then vertically, we are counting 35 boxes all the way from the origin. Then plotting them. Where they meet, we plot them. Then the next one is 0.545. So let's do that quickly. Oh, sorry for that. We just got power failure. We just bear with me, please. I will continue this lesson tomorrow. Thank you very much. Thank you. Thank you. Thank you. Okay.